Okay. As, as we see in the, welcome back again. We see that we have a cosecant. Do not forget about that one. Example number B, 20. So I'm going to leave that one, and you have in the revisions that we have in the chapter 7. So now we are going to new things. We are going to talk about number 4. It's e to power x, and number 5 together, a to power x. We call them exponential. The first, or the number 5, the fifth one is general, and the fourth one is special case. So generally, if I write, for example, we have e to power u du, we see is equal to itself plus c. When I say u du, I mean by hat d hat. Do not forget about that one. We need to have hat d hat. What do you mean? The simplest one is x dx. I'm going to ask myself, derivative of x is equal to what? 1 dx. So that's why I say is equal to itself plus c. How about the next example? If I have e to power 2x dx, in that case I have what? Can you imagine? Can you answer? Think about it, please. 2. We need derivative of here is 2. So in that case, we say is equal to itself, but we don't forget about the balance. So we have 1 over 2 plus c. How about that example? How about that one? Or maybe plus 5. Huh? 1 over 3, you are right. We need the derivative of hat d hat. Do not forget about that word. This will memorizing you, remembering you during the exam. So we have a e hat. So e hat d hat. Derivative of here will be 3x squared. So in that case, we say 1 over 3 itself. Itself is like that, time plus c. You got it, dears? Good. Now number 24, so last one. We have e to power sine of x cosine of x dx is equal to what? Exactly, we don't need minus. Derivative of sine is equal to cosine. So I say is equal to e to power sine plus c, nothing else. That's about natural exponential, the natural exponential. So how about if I have a general exponential? So again, I have number u du hat d hat. We see is equal the same itself plus c, but we add ln of base here. How about the example? Look at the example here. We have 2 to power, for example, x dx, simplest one. We say is equal to what? We say is equal to itself plus c. Because I have 2, I say ln of 2. And how about 2 to power sine of x cosine of x dx? In that case, because I have a derivative of here hat d hat, we see is equal to itself ln of 2 plus c. Do you have any comment? Do you think it's hard? Look at the chapter 7 in at the beginning, I think at the beginning of the chapter 7, we have that one. You can see we have those examples. Sorry. And also we have that one. Look at the examples. All of them is familiar for you. You know how to deal with it. Look at here. You know how to deal with it. And that one also is familiar for you. All of them. So we cover most of the review. Now we are going to 3 important examples. I think chapter 7 is finished. Just that one remains. It's not very important for us for today. So no, let me check. No, the inverse remains, the inverse in chapter 7. And on 7.5 is important for 8.8. Not for now. Here we are. We have these 3 rules. Now we are going to cover 16 and 17 is easy for you. I'm not going to talk about them. Just look at them. It's sine hyperbolic, we called sinh. Cosine hyperbolic, we called cosh. So integral of sinh directly without any minus is equal to cosh. Integral of cosh directly without any minus is equal to sinh. There is nothing to be worried about it. Just put it in. Understood? So I'm going to talk about these 5, especially these 3, which they are formula, inverse formula. For example, if we have such example like that, how we solve it? First of all, we think about ln, right? So derivative of here is equal to what? No, 1 over 2, 1 minus x squared minus 2x. Am I right? This is the derivative of denominator. So we have that one in up, in numerator? No. So we cannot use ln. We cannot use ln, right? Even it's a fraction. I say when you have a fraction, think about it, say 100%. Think about it. Now we don't have it. So the next idea that today we got it was what? It was bring it to up, right? We say bring it to up. The second idea. So that idea, ln idea, is vanished. So how about that one? Am I right? We bring it to up. So can you solve? No, by u du, box d box. Why no? Because the derivative of box is equal to what? Minus 2x. Kaka, about minus 2 is halal, discount, 100% for you. How about x? So we cannot put x here and 1 over x here. We say that it's a taboo. Understood? It's taboo. We cannot add them, right? So, and kindly close the door also. Thank you. So we cannot add them. Understood? So that's why also the idea of bringing it to up is not working here. So how we solve that one? We should go to the inverse, the third thing that we have here till here. We should think about the inverse formula. So I have what? I have that one. So we should think about formula. We have 3 formulas. Think about it. First is sine inverse. Second is tan. Third is second inverse. Tan inverse, second inverse. In these 3 cases, that one without square root, we don't have it. So if I have some square plus something square without saying anything, I say it's a tan inverse. Understood? That's the first. For the 18 and 20, for 18 and 20, we have square roots. You can see here, we have square roots. Look at here. For sine, nothing. For second, we have an x outside the square root of x. So we can distinguish easily, right? If it's without square root, directly I see is equal to what? Tan inverse formula, right? Because we don't have square root. If I have a square root, I'm going to check number first. Number minus variable is sine inverse. Variable square minus number is second inverse. So you need to actually control them, the formula. You need to control them. It's very easy. Doesn't need to solving 2-3 examples. You can control all of them. That's the first, how to recognize the formula, which formula use. The second, A is number. A is number. We should use A as, we should look at A as in number. So if A is not number, we cannot solve it like that. We should change it. So A is number. That's the second. The third thing, look at here. Here we have sine. Here we have 1 over A. Here we have 1 over A. But here, there is no 1 over A. Understood, dear? Understood? So we have sine inverse. Now we are going to solve examples and you know how to deal with them. So first of all, as we say in the example number 27, we have what? We have that example. So how we solve? The steps for solving. This is very simple. If you understand that one, you can understand a little bit advanced one. So A, you should say A is equal to what? Square root of that one. Square root of that one. So is equal to 1. How about if that example is 4? A equal to what? 2. Good. U is equal to what? I say U is equal to square root of here is equal to X. And write du is equal to dx. You know what I mean? I like to change that one to u. You know why? Because that is the simplest formula. I'm going to a little bit make it advanced. U, so u du, u square, u du, u square du, again u. I'm going to change that example like that because later you know what I mean. Not now. Later in the third example, you know what I mean. So how we solve that one? If I have 4, we say A is equal to 2, U is equal to X, du from here, derivative of here is equal to du, derivative of here is equal to dx. So I say directly that one is sine inverse formula, U over A. Any question about 27? I'm going to 28, make it a little bit hard. So we have 6 plus 4x squared dx. Tell me which formula? Tan inverse, because we don't have square root dears. Understood? So we don't have square roots. Okay, so A is equal to what? 3. Well done. No, is equal to square root of 6. We say that. Take the square root. U equal to what? Square root of here is equal to what? 2x, thank you. Du is equal to what? 2 dx, right? I already agree. 2 dx. Understood or not? Shall I repeat it? Good. I like it. When you say yes, I feel you are here. But when you say no and you are not here, make me unhappy. I'm going to compare like that. In my formula, I have square du. So I'm going to compare them. I say a square equal to 6. So a equal to what? Square root for both sides, right? Now you got it now, I think. Understood? U square is equal to what? 4x squared. Now square root of u square is equal to u. Square root for the other side, it will be what? 2x. From here, take the derivative of here. U, derivative of u, du. Derivative of 2x, 2 dx. Am I right? So now I am going to balance them. I need to put what? Am I right? And 1 over 2 outside. Now I have this formula 100%. du, a square, u square. Yes. Now I say is equal to what? 1 over 2 that we have. The formula C is equal to what? 1 over a tan inverse u over a plus c. How about 1 over 2? 1 over 2, it was by balancing, not by rule. So I get what? 1 over 2, yalla. 1 over a is equal to what? You are right. 1 over square root of 6 tan inverse a over. That's it. It wasn't hard, but needs a little bit work. You need to solve by yourself, right? So that's what we have here. Look at that examples. Or later, I'm sure. Do you have any question? So all of them is like that. Now it's time to what? To give you the idea of inverses. Some of them, some formula is not ready. Like what? For example, 28, now 29. If we have something like that, yalla, which formula? None of them, you're right. Why none of them? There is 2x's, thank you. There is no number with minus square, right? We have 4x's, so there's a problem with the x. If I forget about that x, everything is done, right? It will be what if I cancel that x? It will be which formula? Sine inverse, right? You are right. You are absolutely right. So I am going to change that one because there's not just number. I'm going to change that one to something be like number minus variable square du. To change it to like that. You got it? Do you get? Okay, so how we change that one? That's the problem. How we change, I'll be with you. How we change 4x minus x squared to something else. x بابا جوری که حلی نکن. حاضر که بابا شوریه که. او x بابا جوری. 4 minus x equal to 2. Okay, forget about that one. I have a question for you. Question'im هي بلا مكان. أما شيء ما بيود. We see that we recall that one as what? In Kurdish English, don't worry. Exactly. In English, in Kurdish, they told me in Arabic one. No. Another thing. Clear, close to that. They شلون ما نكردوها. First square, how we expanded. First square minus 4x usual plus 4. Am I right? So we call that one as what? شي ما نبيود. Complete square. Do jay tawaf. Right? So it's okay. You forget. Okay. So that's why I mentioned in Kurdish to memorize it. It's okay. I know you know it, but you forget. So tell me, if I have x squared minus 4x plus 4, how I change it to the complete square? How I get it? Pardon? No. Square root of here, 1 year. Square root of here, square root of 4, and the second term or mid-term sign. رقي دو جاي يكم، رقي دو جاي أخير سيم نشانين على الراس. From here we expand. From here we factor. Spelling factor. Okay, you got that one. So if I have 3 terms and it's good, it's perfect, I can make it complete square. Understood? Good. So what's the relation between that one and our work? Now I have 4x minus x squared. I am going to change it to complete square. Because if I change it to complete square, I can get something like that by completing square. That's the idea. So how we do it? That's the question. How I get complete square? For completing square, we have 4 steps. I'm going to mention here. First of all, coefficient of x squared should be only 1. What do you mean by that? So I have 4x minus x squared. I can write down like that. Am I right? Understood? I am going to change the x square to be positive. How? Am I right? Did you understand the first step? Coefficients means that how kolka. How kolki bardam x duja. Coefficients in front of x square or coefficient of x square. You got it here? This is the first step. The second step, I'm going to add and subtract by b over 2 squared. What's b first? First, b is coefficient of x after first step, not from the beginning. So where's the coefficient of x? Here. So what do you mean by that? Show me. What do you mean by add and subtract b squares? It's not easy for me. I say we have that one, and we have that one, and we have that one. Am I right? B is equal to what? 4. First of all, add positive. Add positive here. Then add negative here by square. Where is b? You say 4 or minus 4. Because we have a square, we don't care about minus. Understood the second step, dears? No? Okay. Coefficient of x is equal to what? Here we have minus 4, right? So make addition plus and minus that one over 2. This is the rule. I'm a ruler. زائد ناقصي how kolki x لسردوكا بدو جاي. هرا Maybe you say why. Later I'll tell you why. Oh, that's why you didn't understand, because you don't know why. Now I have what? Akata-chan equal to what? Am I right? Right? Do not cancel it. Positive, negative 4, because we need them. That's why we add. So we need to what? We need to add and subtract minus 4 here. How we get? By b over 2 squared. First addition, second subtraction. This is the second step. Did you understand now? Really? Good. The third step, multiply here to the negative part and bring it to out. Look at me. I see is equal to minus x squared minus 4x plus 4. Look, I should say what? I have what? Plus 4. This is the third. If you have a number, silent. If you have a number 2 here, we say 2 multiply 4 is equal to what? Minus 8. Am I right? For example, if we have 2 instead of minus. You got the idea? اگر ليره الرقم يكم هبويا لباتي ناقص دوم هبويا عمو چه دو كرتي ناقص 4 ناقص 8. Now you understand? So we have, in case we have any numbers here or anything here, we are going to multiply by the last one and bring it to out, kick it to out, throw it to out. Understood? Fourth one, these will be complete square. Fortunately, you got it. The last step, you get the complete square. How? How? We have minus x squared minus 4x minus 4 plus 4 outside. Okay, so I say minus. How I get complete square? We mentioned before. Am I right? X minus 2 square. Easy? Do you get? If you are not sure about it, expand them. First square, 2 multiply them minus 4, second square. So I got what? I got complete square. And what's the benefit of that one? Now we have minus x minus 2 squared plus 4, and I'm going to arrange it nicely like that. Look, now everything is clear. Why clear? Because before we have 4x minus x squared dx. Now I have am I right? So which formula that one now? 100% is sine inverse, 100%. Now we change it, something, look at that example. We change, this is in your chapter, I think 7, yeah, here. We change that one by completing square to get that formula. Now directly I say is equal to what? I say is equal to sine inverse. Where's A? Where's U? Where's du? Everything is good. We don't need to balance u du. So everything is good. I say u over A plus C. Am I right? Understood? So tell me about that one. Tell me about that example. How we solve that one? First, Islan. Kaka Islan? No. Because the derivative of denominator is what? 8x plus 4. Do we have 8x plus 4 here? Huh? Hello? I can't hear you. No, thank you. So len is cancelled. Can we bring it to up? Is 1. It will be minus 1. So no again. So how we solve it? Formula. Which formula? Okay, before completing square, you are right, 100%. But which formula? Can formula in this work that we have? Which one? Tan inverse, right? Because we don't have square root. That's why, thank you. Now I can see you are working. We don't have square root. That's why we say tan. So before we solve, we have an idea. We have an idea. Understood? So that's why I say we need to think about it and change it to the complete square. How we change the complete? We make that one 1. Look at here. We make that x squared to be 1. But between that one and that one, we took a 4, not that one. That'd be that one outside. So, and I put plus minus 1 over 4. See, they skip 2 steps. Do it at home by yourself. You don't need to everything. So then later he multiply by that one and bring it to out. Then you get that formula, which 100%. When you saw that one, you change it to that one. You know this is A and that one U. For balancing, we need 2, 1 over 2, and we get that. Understood? Okay. Look at your lecture 8.1. Example 2, how we solve that one? How we solve that one? Can you tell me? Huh? Which formula? Sine inverse. How we change it? Complete square. Instead of 4, we have 8 and go on, right? Understood, Kaka? That one change to that one and you get the formula. For the rest examples 21 and 22, I'm not going to give you any clue actually. They are the same idea that I see before. For sine inverse, they are two. But look at here. How we control them, how we change, we don't mix them. You can see here we have positive. We don't have a positive before. And here we have x squared, change it to the a squared. Before, if I have a squared minus x squared, I say sine inverse. But if I change that one to x squared minus a squared, I say is cosh inverse. And that one, if I have a square root and positive, 100% is sine hyperbolic inverse. These formula are very, very important for us, and we need them. Do you have any question about? Do you have any question about this table? because I'm going to give you some such more things about another things here. Example number 10, how many? 24. Now I give you two things to prepare you for the next lecture. We have alpha. Oh, sorry, we have a lot. There's many things remains. We have trigonometric and angle, the angle. There's a new things for you. So I'm going to talk about these sticks again. These sticks again. So how to solve them if I have the angle has something else with it. Look at it. When I say trigonometric, I mean, for example, I have cosine. When I say angle, I mean, for example, if I have 5x squared plus 1, and here I have x dx. So how we solve that one? You know, cosine is direct or not? Check. Cosine is direct. Okay. So if cosine is direct, how we solve them? Because we have a derivative of angle here. So in that case, we need the derivative of it is equal to what? 10x. But we have what? Only 10. That's why we need to. So be careful for derivative of that one. So in case the result will be 1 over 10. Derivative of cosine will be sine itself plus c. Now tell me about tan of 2x. يلا جماعة. ده. Tan of 2x. هو شلون حالتين؟ Direct or indirect? Indirect. تانية. We don't have it. So we change it to sine cosine 2x. The same. We say that by ln, but careful, we need what? No minus, without minus also. So we need derivative of here, angle. So we have trigonometric functions with the angle. We need the angle. Understood what I say? So that's why we need 2, and we need 1 over 2 here. So I say is equal to 1 over 2 ln of secant 2x plus c. You got it? Hello? You got it? Are you fine? One more time. Why not? If you have trigonometric functions, it should be angle with it, right? We don't say just sine. Saying sine x, sine theta, sine 5 theta, sine. So we have an angle. With the angle, even it's the direct or indirect, we need the derivative of angle. اگر راست خوکان بون silent please لم شاشا or indirect لو اني بيشوك حل مانك. We need what? The derivative of angle. أمو بيناتشي. Derivative of angle. So we need the derivative of here. Then we can solve. Understood? For example, I say secant square of x is equal to what? يلا جماعة. Equal to what? Secant square? Tan. Why? So I'm going to change that into 5. You should have 1 over 5 here. You got it? So now we have 1 over 5 for 5. Now you understand. This is very important for all of them. For example, if I have cosine, I'm about 33 here. Cosine x to power 3, x to power 2 dx. Trigonometric angle. The angle is what? 3x squared dx, right? So we need 3 to here, 1 over 3 here. So I can say directly cosine, sine x cubed plus c. Now you got the idea, I think, right? Good. I have two things, two last things. Look, I have alpha rule. What do you mean by alpha? If I have cosine alpha x dx, directly I see is equal to sine alpha x over alpha plus c. What do you mean by that? I mean, for example, if I have cosine 5x, directly I see is equal to sine 5x over 5 plus c. The same. Why? Why? Because I have a trigonometric angle and I need the angle. That's why the result is be like that. You got it? Now, the same thing is true for sine alpha. Is equal to what? Share again. Yes. Okay, now we have sine alpha. Sine alpha, again, we can write down like minus cosine alpha x over alpha plus c. What do you mean by that one? Look at that example. We have sine 5x dx. I say is equal to minus cosine 5x over 5 plus c. The same trigonometric angle, the angle. Okay, now why I mentioned that one for you? Because later in the next maybe lecture, we try to solve these together. Sine square, I don't know where is it. Maybe in chapter 5, maybe. That one you mentioned. We mentioned that one also. Forget about chapter. Yeah. I'm going to solve example 7a, b for you. A and B. Next lecture. But for now, I give you the clue to understand some reason. So I have what? I have such rules. We call these rules as a half angle. What do you mean by half angle? For example, if I have sine square of x, we are going to change it by that carefully. That's why I separate to understand. And again, if I have cosine square of x is equal to 1 plus cosine 2x, these called half angle, and we need them. How? Why? How we deal with it? Look at here. If you have 1, you should multiply by 2. If I have 2x, I have what? 4x. Understood? You got it? If I have half, it remains what? 2 by half, 1. If I have 4 again, I'll get what? You got it? So that one is flexible. Do not change the denominators, number 2. Do not change that one. Just change here. So I'm going to write the rule for you. Now we have what? We have nothing, we have 2. Again, it's true for that one. We call that one as square. We call that one as linear. What do you mean by linear? No, linear. What do you mean? Why I say that one is square, that was linear? Linear means that the exponent is 1, خطي, يلي. So that's why here's square, here's 1. Okay, so I cannot solve actually square. I cannot solve square. We should change it to linear by that rule. Understood, dears? You got the idea? Okay. So that's all about today. Kindly, if you have a question, you can ask. If you don't have, let me see. I'll take your attendance. Do you have any question? No? So let me stop the record.